So if we create stacked graph layouts, stacked bar charts, and stacked line graphs of a lot of dependent variables, then you get some interesting effects as displayed here. You start to see kind of a stream effect, and you can see the same data variable evolving as it moves across the horizontal axis. But you also see some other problems with this representation. One is that the variance in the lower variables in the stack can influence the shape of the higher variables, and it can be harder to see when things get sheared towards the outsides whether they're representing the variables the same value or if it's increasing or decreasing. And also you can see that by the time you get to the very top of the graph, it's changing quite violently because it's the sum of all the changes that have happened below it. We can analyze this by using a few variables. If we let each variable at a given horizontal position on the horizontal axis, each variable will be represented by, say, F1 for the first variable, F2 for the second variable, and so on, F1, F2, F3. Then we can define basically ground zero, G0, to be the baseline level. And in this case, we're just setting G0 to be 0, just at the horizontal axis. Then GI is the position of the top of the plot of the ith variable. And the top of the plot of the ith variable, GI, is just equal to G0 plus that variable and all the variables below it in the stack. And we can start to do some analysis. And because of this analysis, there was an alternative layout called Theme River. And Theme River basically centered the vertical plot, the stack of variables, along the horizontal axis. So it set G0 to be 1/2 of the total height of the stack of variables. And by doing that, it basically said that the way this thing is varying at the top will be a mirror image of the way this thing is varying at the bottom. And you get more of the appearance of a river. That data is kind of streaming by and evolving, and it reduced the amount of shearing that was happening, but it didn't eliminate it completely. You can see, for example, this region right here is creating a large shift in the data around it that you'd like to be able to minimize. So just by centering the vertical stack of data around the horizontal axis minimizes the height of the chart around that horizontal axis, and it also minimizes the slope at the top and the bottom. There's a stream graph layout that does an even better job of this, and it does this just by changing where the position G0 is. Stream graph sets G0 equal to the result of this formula. So you just evaluate this formula based on your data values Fi. And we won't go through the derivation of this formula, but by just changing where the base of this stacked bar chart or stacked line chart occurs, and then stacking based to that new baseline, we get an even smoother appearance, and it makes it even easier for us to make comparisons as we move horizontally across this chart to determine relative changes to each of these dependent variables. It minimizes the deviation and the wiggle, the deviation being how far a variable's plot moves from its previous position on the horizontal axis, and the wiggle is minimizing the slope, basically the shear effect that you get from the wiggle. You can also improve the appearance by changing the order in which you add variables. So if variables are 0 until a certain position on the horizontal axis, and then they change from 0 to some value, you can change where they appear in the stack of variables. And so in this case, they're just stacked in some fixed ordering, some arbitrary ordering, and you can see kind of a stream, and the coloring each variable differently helps perceive that stream. In this case, they're colored based on when the variable starts to take on a value other than 0. But you can also add add new variables, when the variables take on a value other than 0, you can always add them to the outside of the graph. And what that does is it takes variables that start out at a certain point on the horizontal axis. As soon as they take on a non-zero value, you add them, but you add them to the outside, so their initial surge in value doesn't disturb the other variables. It's happening on the outside of the graph, and then as it's waning, other variables are taking non-zero values and being added to the outside of the graph, and so you get this nice flowing appearance where you can see the relative change in values of these variables as you move right on the horizontal axis, even though we're looking at 10 or 20 variables in a given stack vertically. So we learned how to make a stream graph and how something as simple as stacking a bar chart can become a point of further investigation in order to how to display it effectively. We also learned that, for example, a pie chart can become misleading, especially when shown in 3 dimensions.